Welcome back to today's session. In the previous session, we described what is transportation problem, and we saw that transportation problem was solved in two phases. The first phase was to compute the IBFS, initial basic feasible solution, and the second phase was for optimization. So we are now discussing that in phase 1, to compute the IBFS, we have three different methods. The methods are northwest corner rule, that is NWCR, next least cost method or LCM, third method is called the Vogel's approximation method or VAM. Okay, so today we will be learning the first method amongst the three, which is northwest corner rule. Okay, so how does this northwest corner rule work? Northwest corner rule or NWCR. So the step one of solving the problem or computing the IBFS using NWCR is starting with the cell at the upper left corner, top left corner, because we are talking about the top left corner. It is called north west corner rule. Okay, so we start from the top left corner of the transportation matrix. We allocate as much as possible so that either the capacity of the first row is exhausted or the destination requirement of the first column is satisfied. That means to say, the quantity of items that I transport from source 1 to destination 1 will be decided here. That is the x11 value. The x11 value will be decided based on the capacity of that particular row and the demand of that particular column. Whichever is minimum, out of the two, whichever is minimum, that will be assigned as x11. Okay, this is first step. The second step says if B1 is greater than A1. What do you mean by B1 greater than A1? The demand is greater than the capacity. We move down vertically to the second row and make the second allocation of magnitude at x21. Sorry, there is a typing mistake here. This is not x22, it is x21. Okay, we make a second allocation of magnitude at x21, which will be minimum of A2, that is the supply of the second row, and B1 minus x11, requirement of the first column minus which you have already satisfied. So this will be done in cell 21. If at all the capacity was more and the demand was less, if B1 less than A1, we don't move down, but we move horizontally to the right. We move right horizontally to the second column and make the second allocation of magnitude at x12, which will be minimum of A1, comma x11 minus B1 in the cell 1, comma 2. If both capacity and the demand were equal, there is a tie for the second allocation. We make the second allocation of magnitude either in x12 or x21 based on any of these forms. Okay, repeat the steps 1 to 2, moving down towards the lower right corner of the transportation table until all the supply and demand requirements are satisfied. So 110%, I know that you have not understood the procedure of solving the problem. You will be able to understand it very nicely and very easily when you solve a problem, right? See, as the steps, step 1, step 2, step 3, if at all you try to remember it and you try to solve it, it will be very tough for you. But for writing the answer, this is required, therefore I have given it. But the process is actually very simple. When you see the problem, you will feel how easy it is. ನಿಮ್ಗೆ ಅನ್ಸುತ್ತೆ ಚಿ ಇಷ್ಟು ಈಸಿ ಪ್ರಾಬ್ಲಮ್ ಅಂತ ಅನ್ಸುತ್ತೆ. So shall we have a look at a problem? Okay, we'll go to the first problem. Obtain the IBFS of the transportation problem whose cost matrix is given below. So because cost matrix is given, it has to be minimization case. And see, the cost matrix given is there are three destinations D1, D2 and D3. There are four origins O1, O2, O3, O4. The supply capacity of each origin is given in the supply rows, supply column. See, O1 has a capacity of 5, O2 has a capacity of 8, O3 has a capacity of 7, O4 has a capacity of 14. And the demand for each destination is also given. Demand for D1 is 7, demand for D2 is 9, demand for D3 is 18, and the cost of transporting one unit from O1 to D1 is 2 rupees, O1 to D2 7 rupees, O1 to D3 4 rupees, O2 to D1 3 rupees, O2 to D2 3 rupees, O2 to D3 1 rupee, O3 to D1 5 rupees, O3 to D2 4 rupees, O3 to D3 7 rupees, O4 to D1 1 rupee, O4 to D2 6 rupees, O4 to D3 2 rupees. So first and foremost thing that we are supposed to do is check whether the problem is balanced. How do we check whether the problem is not balanced or not balanced in transportation? See, when I was giving you the general structure of transportation problem, in a very small line we had just mentioned. You might have even ignored that. I know that. So checking for balanced problem in transportation is add all the supplies and add all the demands. If the sum of all the demands is equal to sum of all the supplies, then the problem is said to be balanced. See, 7 plus 9, 16. 16 plus 18, 34. Now add the supplies. 5 plus 8, 13. 13 plus 7, 20. 20 plus 14, 34. Both the sides, the sum is 34. So the problem is balanced. Since summation Ai is equal to summation Bj is equal to 34. That is, sum of all supplies and sum of all demands is equal to 34. The problem is balanced transportation problem. Now, northwest corner rule, how to solve it? Which is the northwest corner of the entire matrix here in this matrix, in the cost matrix? Northwest is the top left corner, O1 D1, right? This is the top left corner. Here I am supposed to make an assignment. So what was the supply? 5. What is the demand? 7. Out of 7 and 5, which is minimum? 5. So I transport 5 units. So if at all I transported 5 units, the supply becomes 0. What about demand? Demand was 7. 7 minus 5 is equal to 2. Okay. So this row we need not touch again. Right? This row we need not, let me take a highlighter. So this row we need not touch again. This color is not nice. Let me take another color. Blue. We need not touch this row again. Finish. This row is over. So remaining cost matrix is only this part. In this, which is the top left corner, 3. So my next assignment will be made at 3. Fine. I make an assignment at this position. So this row is already deleted because it has become 0. Now look at the supply. Supply is 8. Demand was 2, which is minimum out of the 2. So 2 is minimum. So I am supposed to make an allocation of 2. Okay. So this became 0. So because the column became 0, this column need not be touched again. So 2 minus 2 became 0. This column became 0. So I need not touch. So what happened to the supply? Supply was 8. So I have already satisfied 2. I am remaining with 6. So this is my remaining cost matrix, which is the top left corner, 3. So my next assignment will be made at 3. Have a look. So this row is exhaust. This column is exhaust. Now 9 is the demand and 6 is the supply, which is minimum 6. So satisfy 6 here. So this row got complete and it became 0. So what happened to the demand? 9 minus 6, 3. Okay. So where will the next assignment be? This is the remaining cost matrix. Top left is this, 4. So my next assignment will be at 4. So this row has already gone. This row has already gone because it has become 0. This column has already gone because it is 0. Now remaining was 3. Here the supply is 7. Out of 3 and 7, which is minimum? 3. So I make an allocation of 3 and this column will get cancelled. So I am left out with 7 minus 3, 4. Okay. So this is my remaining cost matrix, which is the top left. Obviously 7. So my next allocation will be made at 7. This row was 0, so it got cancelled. This row also has become 0, it gets cancelled. This column also 0, cancelled. This column 0, cancelled. Now coming here, I am supposed to make an assignment. Here supply was 4, demand is 18. So which is minimum? 4. So make an allocation of 4. So this becomes 0. Okay. 18 minus 4, 14. Still remaining. So now I have come to only one element is left out in the cost matrix. So my allocation should be done there. When I come to the last cell, observe your supply and demand will be equal. If at all it is equal, then all my allocations are correct. So I am supposed to make an allocation of 14 in this cell. See, I have made an allocation of 14. This also becomes 0. This also becomes 0. Now all rows, all columns, demand and supply has become 0. So my problem is solved. Okay. So where all I have got assignment? In first row, first column, I have 5 units. Second row, second column, second row, first column, 2 units. Second row, second column, 6 units. Third row, second column, 3 units. Third row, third column, 4 units. Fourth row, third column, 14 units. So this is my total transportation. Now I am supposed to calculate total transportation cost, TTC. How do you calculate? The number of units into the cost of transport. 5 into 2 plus 2 into 3 plus 6 into 3 plus 3 into 4 plus 4 into 7 plus 14 into 2. Right? Quite simple. 5 2s are 10, 2 3s are 6, 6 3s are 18, 3 4s are 12, 4 7s are 28, 14 2s are 28. So 10 plus 6, 16, 16 plus 18, 34, 34 plus 12, 46, 46 plus, sorry, 56 I believe. No, 46. 46 plus 56, 102. Right? So the total transportation cost is 102. And this assignment structure that you have got is the IBFS. So my problem is solved. So don't you feel the problem is very simple? So when you look at the algorithm, it might appear like a tough problem, but the overall method is very simple. So shall we solve one more problem? Okay. Second problem, I have three origins, O1, O2, O3, four destinations, D1, D2, D3, D4. The supplies are 14, 16, 5 and the demands are 6, 10, 15, 4. So how to solve this? Where you will make the first assignment? There you did the mistake. First, when I ask you for assignment, you should not look for assignment. Check whether the problem is balanced or not. So 14 plus 16, 30. 30 plus 5, 35. Check the demands. 10 plus 6, 16. 16 plus 15, 31. 31 plus 4, 35. Both the sides total are 35. So balanced. Fine. Where will you make the first assignment? Top left corner. So which is the minimum? 6 and 14. 6 is minimum. 6 is the assignment. The column gets cancelled. Now which is the top left? Yes, at 4 you need to make an assignment. How much you will make? 8 and 10. Which is minimum? 8. Very good. So the assignment is done for the row. Updation. Here I have 2 and here I have 16. Where do you make the next assignment? Top left corner. Which is the top left? Perfect. At 9. So how much you will make? 2. Good. So the next assignment is at 9 with 2. Very good. So this row is over, this column is over, this column is also over now. What is the top left? Yes, 2. How much will be the assignment that you make? 14 is there, 15 is there. Which is minimum? 14. Very good. At 2, you will make an assignment of 14. So this row, this column, and this column is gone. How many are left? So here, top left is at 6. So how much you will make assignment? Here you have 1, here you have 5. So minimum is 1. So you are supposed to make allocation of 1. Correct. So at 6, you will make an assignment of 1. So this row gone, this row gone, this column gone, this column gone, this column gone. What is the cell left? You are left with only one cell. So you are supposed to make an assignment here. What did I say? When you have last cell, supply and demand will be equal. Have I got it equal? Yes. So my assignments are correct. So I will make an assignment of 4 at 2. Perfect. So the problem is solved. How will you calculate the TTC now? 6 into 6. Then 8 into 4 plus 2 into 9. Very good. Plus 14 into 2. Good. 1 into 6. Very good. Next 4 into 2. Okay. Have a look at the TTC. Have I written the same? 6 into 6, 8 into 4, 2 into 9, 14 into 2, 1 into 6, 4 into 2. 6 6 are 36, 8 4 are 32, 2 9 are 18, 14 2 are 28, 1 6 are 6, 4 2 are 8. 36 plus 32, 68. Very good. Plus 18, 86. Right. 86 plus 28, 104 plus 6, 120, 120 plus 8, 128. Is that the answer? Fine. Hope you have enjoyed solving the problem. The problem is quite simple, right? Okay. Try solving the same problems on your own once again after seeing the video. Copy the problem, try to solve it. Okay. In the next class, we will be dealing with least cost method. Till then, thank you. Have a nice time. Enjoy. Be at home. Be safe.